We are the boys in motion. We give you our devotion. Boys, we are the boys in motion.
The first video showcases rotational motion. It involves Sophia Lucia doing pirouettes. She does 54 turns or revolutions in 26.14 seconds. If you multiply 54 revolutions by 2 pi, that equals 108 pi, or 339.29 radians.
To obtain angular velocity, we divided the angular displacement by the time. This means we divided 108 pi radians by 26.14 seconds to get an angular velocity of 12.99 radians per second.
To calculate the angular acceleration, we divided the angular velocity by the time. This means we divided 12.99 radians per second by 26.14 seconds to get the angular acceleration of 0.497 radians per second squared.
To calculate the torque, we multiplied the moment of inertia by the angular acceleration. The torque came out to be 18.04 Newton meters after 36.29 kilograms. The girl's weight was multiplied by an angular acceleration of 0.497 radians per second squared.
The angular momentum was calculated by multiplying the moment of inertia, which is 36.29 kilograms, by the angular velocity, 12.99 radians per second. Angular momentum became 471.41 Newton meters per second.
The rotational kinetic energy of Sophia is 3,061 newtons. This was calculated by multiplying half of the moment of inertia by the angular velocity squared.
As she lifts her arms, the radius decreases and the velocity increases, so that she does more spins per second.
The second video demonstrates circular motion of a skippet with a radius of 0.76 meters and a mass of 1.13 kilograms.
We are the boys in motion. We give you our devotion. Boys, we are the boys in motion.
The skippet goes around 18 revolutions in 10.07 seconds. To calculate its angular velocity, we divided the angular displacement of 36 pi by 10.0 seconds. This becomes 11.23 radians per second.
The centripetal acceleration of the skippet is 165.97 meters per second squared. This is calculated by dividing the tangential velocity squared, which is 126.14 meters per second, by 0.76 meters.
The centripetal force of the skippet is 187.55 newtons. This was calculated by dividing the mass times the tangential velocity squared by the radius.
The end.
We are the boys in motion. We give you our devotion. Boys,